Let's go ahead and talk about question 4. Now, if you watch the other 3 videos, again, I'm going to kind of preempt this by saying you're going to see the same kind of stuff. And so if you have done that, you're probably watching this just for the actual answer. Just confirm your own answer. So feel free to skip around as you need to. Okay, so first things first, you're going to see the same kind of formal structure. Certainly the first thing you should do is to very carefully plot out and label your points. And so you can write a nice statement and you can refer to things by their actual name and use a proper notation. In this case, we want to prove that this thing makes a kite, which means, again, we're going to have to go to the definition. I'm going to point out again that even though different classes had slightly different variations, in the end, it's not going to change our work here because we're still talking about proving sides are congruent. In fact, that's what we should probably do first is write ourselves a nice statement of intent. And so let's just get to it. Let's actually shorten that a bit. Okay. So to prove, in this case, a quadrilateral ABCD is a kite. Okay, I will, and then now here's the part that comes in with the definition. If you look at either one of the definitions, it talks about pairs of adjacent congruent side lengths. The only dispute is whether or not they have to be the same. Doesn't actually matter here because we're going to be showing congruencies. And so what we need to kind of consider is what should be congruent to what. So in our diagram, we should show that AD and AB are congruent, and then separately BC and DC, yeah. So that should be in our statement. So if we can prove or show line segment, and let's use proper notation, AB is congruent to AD, and let's see, BC is congruent to DC by using distance formula. Okay. So our statement of intent shows what we want to do, basically definition, how we're going to do it, the distance formula, and now we should add how we know we're going to be right. If the distances are the same, then the sides are congruent. Okay, so just like the previous videos, let's go ahead and very first thing we should do is actually write down the distance formula. So distance formula is defined to be d for distance. Remember, this is just a derivation of the Pythagorean theorem. And so we'll have something like x2 minus x1 to be like the horizontal distance. And then y2 minus y1 for the vertical distance. Now, if you have watched the other videos, you know that I don't like to use this formula. Instead, I like to use this one. Because these are just distances. I don't have to necessarily like show a subtraction problem to calculate it. I can just do that in my head. So that's just really just change in x squared plus change in y squared. Because it is just a distance formula. Okay, so let's do our work for AB and AD. So let's first find the distance AB. Now we're going to need coordinates for this. Now down here I actually have them kind of pre-listed out. Let's go ahead and take a moment to copy them up here so I don't have to keep scrolling back and forth. Let's see, so A is negative 5, comma 7. B is 2, comma 6. D is negative 4, comma 0. And C is 5, comma negative 3. Okay. All right, so to use, to find the distance AB, let's actually change color. So to find the distance AB, let's just find some distances. Okay, so A to B goes from, let's see, the x goes from negative 5 to 2. That's the distance of 7, so we'll square it up. At the same time, from A to B goes from 7 to 6. That's just a distance of 1, so I'll square it. So this ends up being the square root of 50. 7 squared is 49, 1 squared is just 1, so square root of 50. Let's compare that then to AD, using the same kind of logic. Using the distance formula again, of course, because we need to show a calculation to prove this. Going from A to D, let's see, A goes from 5 to negative 4. That's just a distance of 1. And then it goes from 7 to 0 for the y, as that's a distance of 7. And again, we can see right there, it's going to work out. 1 squared is 1, 7 squared is 49, so that's the square root of 50. So we managed to show at least AD and AB are congruent. So we're good to go on that front. Let's go ahead and switch over and find BC and DC. So let's go find BC. Okay, so going from B to C, it goes from 2 to 5. Yeah, 2 to 5, which is just 3 squared. And then 6 to negative 3, which is 9 squared. So 3 squared makes 9. 9 squared makes 81. And so that will just be the square root of 90. Now, I know it's not the square root of 50, but remember, it didn't have to be. We were showing that AB and AD were congruent, which we did because they're both the square root of 50. And now we're going to find BC and DC are congruent separately. And so far it's working out that they're not going to be all the same, but that's okay. They don't have to be. Let's find, what do we have left? DC. Okay, going from D to C goes from negative 4 to 5. That's a 9 squared. The y's go from 0 to negative 3. That's a 3 squared. 9 squared plus 3 squared, that's going to be 81 plus 9 again. And so that's going to be square root of 90. Okay, and so if you recall our statement, we're going to show that AD and AB are congruent by using the distance formula. We did that. They're both square root of 50, so they're congruent. And then separately, we're going to show BC and DC. We did that to both square root of 90. And so if we go back to our big picture, I believe we met the burden. We've shown that these two sides are congruent, and these two sides are congruent separately. Now, we can separately argue whether or not they should all be the same or could be the same, but it's moot in this example. We just had to prove it's a kite. We've met that. We do have a secondary thing we need to do. Prove that prove that the diagonals are perpendicular. And so going back to our drawing, let's first augment it to make sure we know what we're talking about. So diagonals are these two lines. Okay, and to prove the perpendicular, well, we're going to have to evaluate some slopes. And so, let's see, ACPD, okay. Let's first write a statement so the reader knows what we intend to do. So to prove these are perpendicular, okay, to prove AC is perpendicular to ABD, which are the two diagonals that I named and drew in my diagram. I will show they have opposite reciprocal slopes, because that's a definition of perpendicular. And I'll tell you how I'm going to do it by using the distance formula, or I'm sorry, by using the slopes formula. In other words, I'm going to calculate the slope separately. I'll calculate the slope of AC. I'll calculate the slope of BD by using the slope formula to show that they are different. And so let's go right here in the middle. And I'm just using the middle because that's my personal choice. And I'll remind myself that the slope is the same thing as rise over run, which is the same thing as delta y over delta x. And delta y can be calculated just by looking at the difference of the y's. And then delta x can be done the same way, x1 minus x2. So that's the slope. That's the actual calculation that I'll be performing. Okay? So let's show this over here. Let's calculate the slope of AC. So going from A to C, change in y over change in x. A to C, the y goes from 7 to negative 3. At the same time, on the x's, we're going negative 5 to 5. So on top, that gives me 7 plus 3, which is actually a positive 10. On the bottom, we have 5 minus 5, which is a negative 10, which means the slope is just negative 1. This is good news. That tells me that if these are perpendicular, all I have to show is that BD slope is going to be positive 1. Let's check it out. We're going to go back to the slope formula, delta y over delta x. I'm going from B to D this time, so we go 6 minus 0 on top. Change in x at the same time as 2 subtract negative 4. So on top we have a 6, on bottom we have 2 plus 4, which is also 6. Therefore it's just 1. Well, if I have a slope of 1 and a slope of negative 1, which I do, those have to be perpendicular because they are opposite reciprocal by rule. And so they've been flipped and negated because, again, side note here, negative 1 can be looked at as negative 1 over 1, and then 1 can just be 1 over 1. So they have been flipped, so the negative 1 flipped to the bottom. They're all 1, so it's really a moot point. But the important part is that negative 1 turned into a positive 1. Okay, so that's what we have for Kite. Again, just to review the pieces, make sure you have a nice diagram is where you're going to do your thinking. Make sure that you have a nice statement of intent that's kind of in 3 parts. What you're trying to do, how you're going to do it, how you know you're right. It has to be backed up by some calculation, which I have here. In this case, use distance formula. And same is true even for a smaller example. We still have to write a nice statement of intent, show a calculation to prove anything that we're asked to prove. All right, so that's part 4. One more part 5, and then that will be this.